For this EVE302 project, my teammate and I decided to model our experiment around the contaminant Agent Orange. Agent Orange was present during the Vietnam War, where the U.S. military services uses as a tactical herbicide on Vietnam forests to get rid of the vegetation so that the Vietnam troops will have nowhere to hide. Agent Orange contains a very toxic chemical, which is TCDD. The effects of it are birth defects, cancer, and skin disease. A lot of Vietnam veterans come back with cancer, and after that, when they have children, the children will suffer a lot of birth defects. The approach to it is pyrolysis, which is heating soil at high temperatures. The competing technology would be industrial pyrolysis, where they can excavate large amounts of contaminant soil and heat it under high temperatures. The way we model this experiment is we use a muffle furnace to simulate high temperatures. We were able to use a muffle furnace at the ISTB4 lab that can go up to temperatures of 600, 800. We used an aluminum tray as it's unreactive and wouldn't melt with the sand. We use silica sand instead of soil because it contains because soil contains organic material that will be hard to extract the dye from. To make the sand mixture, we had to dilute the red dye down to a 1% volume solution. We then took 200 grams of silica sand and put 1% of volume solution, but we didn't totally submerge all of the sand in the solution. We just wet the sand just enough. And after that, we distributed that sand dye solution, 10 grams each, into every aluminum dish that we had.
The method used in this experiment is visible spectrophotometry, and it's a method used to measure how much a chemical substance absorbs light by measuring the intensity of light as a beam passes through a sample solution. And each compound absorbs or transmits light over a specific range of wavelength, which for our compound was 0.525 nanometers, which is the wavelength at which we measured all our absorbance at. Firstly, we created a calibration curve with 4 solutions that we created with a known concentration of dye. And then we measured their absorbance and created this line and graph so that when we measured the absorbance of the solutions after pyrolysis, we will be able to trace their absorbance back to the concentration of dye remaining in them. We then went on to contaminate the sand with our contaminant, which in this case was red dye, and we measured 10 grams of the whole mixture and put them on aluminum plates, and we had 4 different plates for each temperature, as we left each plate in for a different amount of time. We then put the plates in the oven, 1 for each temperature, 4 plates for each different temperature, and they were left in for a time of 5, 10, 20, and 30 minutes. And then after the mixtures were removed from the oven, we went on to place them on filter paper and remove the red dye using 10 milliliters of acetone. Once we had our solution, we placed them into small vials that we then placed in the spectrophotometer to measure their absorbance at the peak wavelength of 0.525 nanometers. Our results at 100 degrees was that we saw that the absorbance decreased quickly from 5 to 10 minutes, and therefore the concentration remaining did too, as they are directly proportional. And from the time of 10 minutes to 30 minutes that they were left in the oven, we can see that the concentration of the dye or its absorbance remains constant, which led us to think that all of the dye was removed after. At a temperature of 200 degrees, we saw that the absorbance was constant for all the different times that we placed the mixtures in the oven, and the absorbance was also really low, which means that the concentration was much lower. That led us to think that at 200 degrees, after 5 minutes, all of the dye was already removed by pyrolysis from the mixtures. So then we decided to do a last trial with 50 degrees, and we obtained a graph that we expected from pyrolysis, which is that as time goes on, the absorbance decreases, and therefore the concentration remaining decreases. And from this graph, we can see a steady decrease in absorbance and concentration remaining of dye in the mixtures. This is a chart with all our main results, and we also conducted a trial a control trial at 25 degrees for 30 minutes, just to measure the absorbance and therefore prove that with pyrolysis we actually did remove red dye, or the concentration, and decrease the concentration of red dye in the mixtures. Our results show us that as temperature increases, the amount of contaminant removed increases, and that is the same relation with time. As the more time a mixture with a contaminant is left in an oven with pyrolysis ongoing, the less the concentration remaining will be. However, we did find that this reaches a critical point where the contaminant won't be removed anymore, and therefore applying this to the removal of Agent Orange, the right temperature should be found where all the contaminant can be removed, but also the right time at which all the contaminant is removed has to be found in order to make the process as efficient